in lecture lab number 3 we have looked at students. Let's start our lab number 4. In last lab number 3 we have looked into Wireshark, getting started Wireshark and how to use the Wireshark and what is the interface, what is the component of the Wireshark and how it works, basically how it captures the packets, and how the analyzer in the packet sniffer will analyze the packet. Okay, today we are going to look on in the last lab we looked the command menu, display filter option, and listing of the captured packets and the details what is contained in the segment, packet or frame, and application layer header and content of the packets. Okay, so and I have given you one homework for the lab, okay, which contains some questions, so you have to submit that homework. I hope all of you have submitted that homework also. Today we are going to start lab number 4. In lab number 4 we are going to basically look into the working of the TCP and HTTP protocol. We studied in our lecture HTTP protocol. Okay. So in this lab number 4, what we are going to do, we are basically going to look the simulation mode for the HTTP message. Okay, this is the pre lab activity. You have to study chapter number 2, which we have done already. We have to create this topology having a server and switch with two client computers. Okay, so let's start with the packet tracer to create this topology so that we can run the simulation after creating this topology. So we have to run the packet tracer. Okay, in the packet tracer let's start creating the topology in the packet tracer. Run the Cisco packet tracer, connect two devices. Okay, here on the packet tracer. Okay, connect two PCs to a server through a switch. Okay, as shown in the figure. So just take two PCs, okay, general purpose computers like this, one PC and another PC. You take one switch, okay, and you take one server. Clear? Now you have to connect the devices. Okay, in order to connect the devices you will use the connection here. These are the connections. It is written here, connection. Okay, I will bring it up little bit so that you can easily look here. This is the connection. Okay, here this is the button. Okay, now you can select either automatic connection. If you look here, it is automatic connection, but I don't want to select automatic. As I have told you that if you want to connect different type of devices, you will use the straight through cable, and if you want to connect same type of devices, you will use crossover cable. As these are the different type of devices, that is why we are going to select the straight through cable. Okay, in straight through cable I am going to select this PC. I am going to connect this PC with port number 2. One I have left for server. Okay, again a straight through. This PC fast Ethernet port I will connect with the switch fast Ethernet port 03. Again a straight through cable from the server fast Ethernet I will connect it on the fast Ethernet 01. Okay, now the topology is complete. The topology is complete. Connect two PCs to a server through a switch as shown in figure. This figure. This we have done already almost here. Okay. Now what we have to do, we have to assign the IP addresses for the server and the two PCs as following. Server should be assigned 192.168.1112, PC01 and PC13. Okay. Let's start with PC0. Assign it 192.168.1111. Okay, PC0. Let's assign it an IP address 192.168.1111.1. This is the default subnet mask. Okay, close it. This server should be assigned desktop IP address configuration 192.168.1111.2. Okay, this is the subnet mask. IP addressing we will study in detail in IP addressing lab. Okay. Right now I'm not going to discuss this issue that what is these things. Okay. Just the main aim of this lab is to understand the working of HTTP and TCP protocols. HTTP on the application layer, which we studied in our lecture, and as we studied that HTTP does require a connection setup. So connection setup is possible only with the TCP protocol on the transport layer, and HTTP requires a reliable delivery, which is only possible with the help of TCP protocol on the transport layer. Okay, so that is the purpose of this lab, to understand that working. Okay, clear? So this is the IP, this is the subnet mask or the server, and close it and go to this PC, assign it an IP address. Okay, 192.168.111.3. okay, and then close it. Okay, now if you want, you can check it whether it is connected or not. Just click here, click on the command prompt and check it. Ping itself 192.168.111.1. if the reply comes back, it means the IP is assigned correctly to this computer. You can either ping on the IP or you can ping on the loopback address 127.0.0.1. this is also there to check the TCP IP protocol suite is working on this computer perfectly or not. And if you have assigned the IP address, then you can ping on the IP. Now from here you can check, you can ping the server and you can test whether it can ping to the server or not. 192.168.111.2 is the IP of the server. Look here, 192. Let me bring it up little bit so that you can clearly look. 192.168.111.2. This is the IP of the server. Now look, the reply is coming back. It is going to send 4 packets. 4 packets are sent, 4 packets are received. Lost is 0. Okay, so it's mean there is no loss, 0% loss. Okay, so approximate round trip time, this is round trip time in milliseconds, is minimum 0, maximum 1 millisecond, and the average is 0. Okay, so 4 packets are sent and 4 are received back from the server as a response. Ping is a command just to test the connectivity between the two hosts. If the other host is working properly, it will receive and send a reply back. Now check the PC number 3 whether PC1 can communicate, PC0 can communicate with PC1 or not. It can communicate with itself, it can communicate with the server. Can it communicate with the PC1? Just ping PC1 whose IP is 1113. So a reply is coming back. It means your network is complete now. This LAN setup with 2 PC, 1 server connected through the switch is complete. Clear? Now let's look here. Till here we have done this. Okay. Now let's have a look on the next part. Click on the server and then press the config tab. You will see some services there the server provides to the client, such as HTTP, FTP, DNS. Press HTTP and then either you modify the default page, index page, or create your own page. Click on PC0, then desktop, then on the web browser request the default page on your own default page or your own page which you have created by typing the URL, which is the server ip/index.html. so the page will be open on your browser. Okay, like this. You go and check it. Okay, now what I'm going to do here, I'm going to close it. Oh, it is here. Yeah, let me check. Yeah, it is recording properly. Click on the server. Okay, then click on the config tab, click on the HTTP and check the HTTP service is running. Yeah, it is on, running. HTTPS is running. This is the web page. Okay, also check whether the DNS is running or not. The DNS is off. DNS service, I don't need the DNS because I'm going to give the IP address. I'm not going to give the URL. So this will be discussed in the next lab. Okay, just close it. Just open this computer, open the web browser and right here, as it is mentioned in your lab, you have to write here http :/server IP, after that index.html. You can write it or you can copy and paste it in the browser of the computer like this. Here you have to change the IP address. Here you have to put the IP address 192.168.111.2. Is it the IP address of the server? Usually we write here www.google.com, and that request will go to DNS. DNS will resolve it, and then it will go to the server. But right now we have not DNS here in our setup. So that is why we are putting the IP directly. And on that, http :/IP of the server /index.html. Clear? If I press the go, the page will be opened here. From where this page came? From the server. Clear? Now you have to look that how this page came. Here in less than 1 second the page is opened. But what is the science behind bringing this page on into your web browser? How this page came actually? This we have to study in this lab. The purpose of this lab is that I have to explain you that how HTTP is going to request the services of the TCP protocol on the transport layer to set up a TCP connection first with the web server and then retrieve the web page from the web server into the client browser, web browser. Clear? Yes. Now close it, come here. This we have looked into it, okay. We got the page, okay. This we have seen, okay, as well as the page is open. Okay. These are the snapshots, okay. Now what is the format of the HTTP message basically? Okay. Now we have to look into the simulation mode, that how this page is opened. Okay. For that you just click here. Okay. Open the browser. Again type the URL. Replace the server IP. Replace the name with the server IP address. Okay. Don't run it. Just click on the simulation now. The request is ready on the client. Okay. The request is ready on the client. Now the client is going to send the request. Okay. When I press here go, the request is ready on the client, but yet it is not sent to the server. I will send it in the simulation mode step by step to explain you how it goes from the computer to the switch, then how it goes from the switch to the server, and how it is processed. Now you look here, when you press go, the request is ready here. Now here are the options: capture and forward and auto capture. Auto capture will run the simulation in one go and stop it. Auto capture will capture and forward will be step by step. The control is in your hand. Okay. Now the request is ready here, and this request is for the TCP connection. Layer 7 message is going to layer 4. Okay. Why? To ask for a TCP connection. Look here. TCP source port is 1026. I told you that the source port, the well-defined ports are from 0 to 1000, 0 to 1024. The ports are well defined. The client operating system will assign a port to the client greater than 1024. Right now, to this computer, the operating system of this computer has assigned a port number 1026 to this client, 1026 to this client. And the port number where the request has to go, the destination port number is, this is your client computer. The client OS has assigned it a port 192.168. This is the IP of this machine, and the port number is assigned 1026. The server IP is 192.168.111.2, and the port number of the server is 80. This is the destination IP. Clear? This is the destination port. Greater than 1000. the greater than 1024 is the client port, and a smaller than 1024 is the server port, which is well defined over here. It is 80 for HTTP web server. Clear? Have you seen this thing? Clear to you? Very good. The request will go from the application layer of the client computer to the transport layer. Transport layer will define the source port and the destination port. Then if you type next, the request will come to the network layer. Which layer model? 7 layer model. 1, 2, 3, 4, 5. 7 are the OSI layers, but TCP IP model is a 5 layer model. Physical, data link, network, transport, application. Now the message from the application layer, it went down to the transport layer, okay, and the message is divided into segments, and segment is having the source port number and the destination port number and the segment number inside the segment header, and the source port is 1026, which is the port assigned by the operating system of the client machine, and the destination port is 80, which is the port of the web server, destination computer port. The web server process is listening on port number 80, and the client process is listening on the client machine on port number 1026. Clear? When the segment will come down on the network layer, it will be encapsulated into IP packet. Clear? The IP packet header will have the source IP address, which is 192.168.1.1.1. Look here. And the destination IP address, which is 192.168.1.1.2. Look here. Is it clear? Where is the segment? Where is the segment? Where segment has gone? Is it encapsulated in the packet? Segment from here, it came down. Is it encapsulated inside the packet? Encapsulation. The sending computer is doing encapsulation, guys. I made here on the board the complete diagram. The division of the application layer message into segments. Each segment is having attached an header with it. Who attaches this header? The transport layer. It will put in the header of the segment source port and destination port and the segment number. Every segment will go down to the network layer, and it will be encapsulated into a packet, and the network layer will put a packet header with that packet containing the segment inside it, and the packet header will contain the source IP address and the destination IP address. When the packet will go on the data link layer, it will be encapsulated inside the frame, and the data link layer will attach a header with the frame containing the source MAC address and the destination MAC address. I told you the frame contains all the information: source MAC, destination MAC in the frame header, source IP, destination IP in the packet header, source port and destination port in the segment header. Segment was encapsulated in the packet, and packet is encapsulated in the frame, and frame contains everything. Frame contains inside it the packet, and the packet contains inside it the segment, and segment contains inside it the part of the message of the application. Don't forget, guys, this thing, please. If you have to study this course, and if you want to understand the concepts, please read the slides, lecture slides, read it from the book, whatever material I am giving you. Okay, in the lab I have told you to look on the two websites, www.net-seal.net, www.network-tools.com. Please browse these websites if you want to get clear your concepts in this course. Clear? It is written here, the description is written here: the source IP address is not specified, the device set it to the port's IP address. The destination IP address is the same subnet. The device sets the next hop destination IP. Next, the IP packet will come on the data link layer. The data link layer will encapsulate it into the frame and attach a frame header. Frame header will contain the source MAC address and the destination MAC address. Okay. Then it comes down to the physical layer, and on the physical layer there is the wire is connected on fast Ethernet port 0, and the frame is divided into bits, and bits are sent onto the fast Ethernet port 0 in the form of electrical signals, voltage pulses. Each signal level represent one bit. Different signal levels are there, voltage levels are there to represent different bits. Clear? So send out the frame and finish. It is at device 0, and this is the source, and the destination is the server. Clear? This is the OSI model. Outbound PDU, you can look here in the PDU formats. If we start from here, this is the transport layer segment, which will have the source port. This is the header of what information is contained inside the segment. TCP segment contains the source port and the destination port, sequence number, acknowledgement number, offset. Okay, these all are the information contained inside the segment. When the segment goes to the network layer, it will be encapsulated in the IP packet, and the IP packet will contain the source IP address of the client and destination IP address of the server. Clear? Then this is the data part. This is the data part here. This is the data part here. When the IP packet goes to the data link layer, the IP packet will be encapsulated into a frame, and the frame will contain the source MAC address, which is the MAC address of the client computer, and the destination MAC address, which is the MAC address of the server, web server. Clear? And the data will be here. Now this is the protocol data unit formats, or their headers and complete details inside it, along with the header information plus the data part. Clear? Now still the bits are not transmitted on the media. Now I am going to type it capture forward. The bits are going to be sent to the switch. Okay, look here. From these were at the device PC0. Now the last device is PC0, and the bits are received on the switch. If you click here, switch is a which device? Switch is a layer 2 device. So you can see only 2 layers here, because it can work on layer 2 and layer 1 only. Computer is a general purpose device. That is why on computer you can see all the 5 layers. But here on the switch you can see only 2 layers. When the packet is received at the switch, if you click on that packet, on that frame, you will look into the switch only 2 layers, because it is a layer 2 device. There are multi-layer switches also, which can work on multiple layers, layer 2 as well as on layer 3, but this is a layer 2 switch. Okay, so you can find here only 2 layers. The packet is received on port number 2, because I connected, do you remember I connected this PC on port number 2? Do you remember it? See, on port number fast Ethernet 2, the packet is received on port number, the bits are received on port number 02, okay, and the bits are completed when it will be in the shape of a frame. The frame will be forwarded to the data link layer. Okay, the data link layer will receive the frame, and in the frame there will be a source and destination MAC address. The source, it is coming from 9525, this computer, this is hexadecimal format, 48-bit, okay. It needs to go to 24/7C to the server. This is the MAC addresses, source MAC and destination MAC. This is layer 2, this is Ethernet header, Ethernet frame header. The switch will check in its MAC address table that this destination MAC is connected on which port. You know that this destination MAC is connected on port number One of the switch. So this switch send out this frame on port number? Port number 1. Look here, 1. Can you see here 1? FA01, fast Ethernet 01. So the switch will send it look into the source MAC and destination MAC and forward. The job of the switch is to forward the frame received on port number 2 and forward it to port number 1. It is going to look into the source and destination MAC, and this destination is connected on port 1. It will forward it to port number 1, and from here it will go out. And it will have inbound, which is coming, source MAC and destination MAC, and this is outbound, source and destination. The Ethernet frame contains the packet and it contains the segment inside it. Have you seen with your own eyes what I told you? That the frame does contain in its packet and the packet does contain in it the segment. You have seen the three things. It is a layer 2 device, but frame is on layer 2, but it contains the data of layer 3 and layer 4 and layer 5. Application, transport, network. Application data, transport segment, network frame contained inside the frame. That is why if you capture the frame, you can get the whole information, all the information. Here, this is very important to understand this concept here at this moment is very important, because when you will use the Wireshark and you have to capture the frame, you have to look into this whole information, all the information. Application layer protocol, its data, transport layer segment, its source port and destination port and the segment numbers and the sequence number and the acknowledgement number, data link layer packet, its source IP address, its destination IP address, network layer packet, IP packet, its source IP address, destination IP address, data link layer frame, its source MAC address, its destination MAC address. Clear? If this concept is clear, it will be very, very easy for you to understand the next advanced topics and concepts in this course. Clear? This is the outbound and it has gone out. I will press it and it is received. The frame is received on the from switch, PC to switch to server. Now what the server has received, because server is a general purpose device, okay, it can process on all the layers, 4 or 5, okay. Yeah, it is received on port number 0, fast Ethernet port number 0 of the server, not of the switch. From switch it is out now. It is entering into the port number 0 of the server, because when we connected server with the switch, it was port 0. Here, fast Ethernet frame is received on, bits are received on fast Ethernet port 0. It receives the frame, it sends it to the upper layer. It is coming from the source 9525 and for the destination 247C. This is the destination MAC address in the frame. Now the server will check, is this MAC address for me? If this MAC address, destination MAC address in the frame header matches with my destination MAC address, it means this frame is destined for me. It is my frame. It means I can de-encapsulate the frame, because the client did the process of encapsulation. Now the server is going to do the process of de-encapsulation. So the server will de-encapsulate the frame, open the frame, and from the frame it will remove the IP packet. What it encapsulated in the frame? IP packet. The server is going to de-encapsulate the frame and it is going to remove the IP packet from the frame. Clear? After removing the packet from the frame, it will send the frame to the network layer, its upper layer, because it is going to serve the network layer. Okay, it is going to send the frame to the network packet, extracted the packet from the frame and going to send the packet to the data link layer. Clear? Now the job of the to the network layer. The job of the network layer here is to look into the header of the IP packet. It is coming from the source MAC 1 as source IP address 1, source IP address 192.168.1.1.1, and the destination IP address is 192.168.1.1.2. What is my destination IP address? Server will check. My address is 2. So what is the destination IP address in the IP packet header 2? It's mean, is this packet, IP packet is destined for me? Yes, it is for me. So I am the one who can de-encapsulate it because it is destined for me. It reached on a correct destination. So the network layer on the server will de-encapsulate the IP packet. When it will de-encapsulate the IP packet after confirmation of the destination IP address with its own IP address, it will remove, it will de-encapsulate, it will extract the segment from the IP packet. And where it will send the segment? To its upper layer, to the transport layer. Clear? It is going to send the segment to the transport layer. The job of the transport layer on the server is to check in the header of the segment what is the source port and what is the destination port. Source MAC, source IP and source port is very important because when this server is going to send a reply, it will make these sources as destination. Everything will be opposite. This is the receiving time. At the sending time, the source will become destination. Source port will become the destination port. Source IP will become the destination IP. Source MAC will become the destination MAC. Clear? Look here. The source port is 1026, which is the port of the client computer, and the destination port is 80. Clear? It's mean, is any process on the server running which is listening on port 80? Yeah. A HTTP process, which is the web server process, it is running on the server and that process is listening on port 80. That process is running, listening on port 80 on this server. So it's mean this segment is destined for that particular process, because on this process, on this server, many processes will be running at the same time. You have seen in the task manager how many processes can run simultaneously at a computer, at one computer. Okay, so might be at that time. That is why the port numbers are used to differentiate it. Look here, 59 processes are currently running on this client computer. So how the server which is receiving a segment, how it will recognize that this segment should be delivered to which application layer process? Because every application layer program will have its corresponding process to receive this segment and further process it. So the HTTP web server application will be running at the back end web server process, HTTP process, which is listening on port 80, and it will be delivered this segment too. Clear? And after delivering it, it will process it. It will look into the data of the segment, what is there. In the data of the segment, it was written that I need to get the index.html page, which is hosted on this server. So now it will look here. This is an arrow here. Can you look here, an arrow? Now this segment is again going to be encapsulated. This was the process of de-encapsulation on the server. Now the server is going to again encapsulate the segment into the data into the segment. So it is going to put a response in the data part of the segment, and the response contain the web page for which a request came here, because this segment contains the request http://192.168.111.2/index.html. This was there in the data part of the segment, which was a request to get this web page. It was a get. Have you seen get? In HTTP we studied get, and in the get we have given a URL. That URL is there in the body of the segment. Clear? It is going to prepare a response 200 OK code. Do you remember the code 200 OK to display the page? Response is prepared in the TCP segment, and the header of the TCP segment now contains the source port is, who is going to send a reply now? Web server process, and web server process is listening on port number 80. It is going to send a reply now from server process to the client process. Now the server process port number is 80, which is the source port, and the destination port will be the port of the client, which was 1026. This segment, in the body of the segment there is a response message, and in the header of the segment there is source port 80 and destination port 1026. 1026 mean on the client computer, the process who is listening and at port number 1026, he will be responsible to receive this segment and process it further. Clear? This segment, next, this segment is ready now. Okay, it is going to be sent down to the network layer on the server. The segment will be encapsulated in the IP packet, and in the header of the IP packet it will be written source IP address 192.168.111.2, which is the IP address of the server, and destination IP address is 192.168.111.1, which is the IP address of the client computer from where the request came. Now that has become the destination to receive the reply back, because the reply is going to response is going to send to that destination, which is the client computer now. Clear? And the protocol here is IP. On the transport layer the protocol was TCP. Now the IP packet will be sent down to the, this is the process of encapsulation going on now here. The IP packet will be sent down to the data link layer. The protocol on the data link layer is Ethernet, and the IP packet is going to be encapsulated into the Ethernet frame, and in the frame header the data link layer will put the source MAC address and the destination MAC address. Look here, this was the destination MAC, now it has become the source, and the source has become the destination. Source IP has become here the destination IP. Destination has become the source. Source port has become the destination port, and destination port has become the source port. Everything is opposite now when it is going to send a reply. So this is a frame. Frame will complete frame containing everything inside it. It will come down to the physical layer, divided into bits, signals, whatever, connector, voltage, type of media. Okay, it will be sent out arrow from the fast Ethernet port 0 of the server. Okay, these are the detail inside Ethernet frame, IP and segment, and this is incoming and outgoing frame. Clear? Now the reply will come back to the switch. If you click on this, again it will be showing only two layers. You are familiar with it. Switch will look into the switching table. Okay, it will look that it is coming from the server and it has to go to this. Where is this? It is on port number 2 of the switch. It will send the packet on port number 2. Okay, port number 2. Look here now. Just keep here this window. Yet the page is not opened. Why? The frame is not received here. As soon as the frame will be received here, the page will be displayed. I want to reduce it. Now you keep an eye here. I am going to send it. Look here. Now it is received here. Okay. Look here. From switch to PC0, and at PC0 I am going to look into it at PC0. from switch to PC0. It is received here. It is received here. The connection setup is complete. The connection setup is complete. This green packet was showing the connection setup. Yet the HTTP request was not sent. Sorry for that. I told you that in the segment it contains the request for the web page. No, sorry. It was a TCP protocol used. In the segment part it contains the request to establish a TCP connection first. So the TCP connection is established. Now the request will go for the HTTP page. Clear? First the TCP connection has to be established, which is established now. Look here, this is indicating the TCP connection is established. Now the HTTP request is going to be sent for the page. Clear? Now the HTTP request is going to be sent for the page. Now the HTTP request is ready on the, look here, on the application layer. Look here, the application layer. This is the application layer, layer 7. It contains the HTTP request now. Clear? This request is going to be sent now. Okay? This request is going to be sent now from this computer to the switch. Okay? This is at PC0, PC to switch. Okay? PC to switch. Okay? Okay? Then from switch to also the acknowledgement was sent. With the HTTP request, the acknowledgement was also sent. Three-way handshake. Sync, sync plus acknowledge and acknowledge. Okay. The HTTP request is received on the server. Okay. And it contains, it will go up now. Okay. In the simulation mode. It will go up. It will be processed. The reply will be sent back from the server to the switch. And look here, the page is open. The page is open now. Look here, the page is open. The page is open and the TCP connection is closed. The page is open and TCP connection is closed on layer 4. Who established it? TCP protocol on the layer 4. It is closed now. Clear? Page is received, connection is closed. And this is HTTP non-persistent. In one TCP connection, only one object will be transferred. If it is HTTP persistent, in one connection, more than one object can be transferred. Clear?
The request must be go to that.
Yeah, two requests. One for the TCP connection setup, one for the HTTP request. So the first TCP connection request, when it will be sent, the segment will contain the request to set up a connection with the web server. And the second HTTP request segment body will contain the URL of the page to be retrieved from the web server. Sorry, I told you that the first segment body will contain the web page address. No, first segment body will contain the request to set up a TCP connection with the server because it was a TCP segment. And the next segment will be TCP segment, but that segment will contain the HTTP request, which that segment body will contain the URL of the page to be retrieved from the web server on the client. Clear? Clear, guys? Is
So
the it,
for every object it will go twice?
yeah, it has, because the connection is tear down. For next HTTP request, you again have to set up a TCP connection. Clear, guys? So this is our lab actually. The lab is finished. This is again is going to send repeat. Okay, you can reset the simulation from here. Okay, this is our lab. We have done the lab. I'm going to save this lab here on your computer. Okay, this is the lab number 4. Working of TCP and HTTP protocol. Okay, lab work. Clear? Okay. You have some homework here as well. Please look here, guys. Exercise homework 2. First homework was the Wireshark. You have done and submitted it. Second homework is I have explained you the working of HTTP with the TCP. Today I taught you FTP with the TCP. So you have to bring the working of the FTP protocol report. That what is being done. Okay. Submit the report for the message exchange for one of the application layer protocol other than HTTP using the simulation mode in packet tracer, for example FTP. Okay. So you have to show the working of the FTP. This is the working of the HTTP here. Okay. The next is you have to bring a report and you have to write what is being done. Okay. Or you can do, okay, simple you can do, don't bring any report. You just run this, please make this topology in the packet tracer and bring your laptops to show me the simulation. How you will fetch a file. Username and password. First TCP connection setup. You will give a username and password to set up a TCP connection. Then you will list the files on the FTP server. Then you will get or post. Get will download a file and post will upload a file. You have to show me just the simulation on the packet tracer. Okay. Once you show me the simulation, I will grade your assignment number 2, which is the FTP working in the simulator with the simulation. Clear? Thank you.